Hello, this is question 5 on your mixed exercise 4 from year 12, and you have this function here and we have to sketch it. This function here is a quartic, so if you expand this bracket you have x squared xx is a quartic, and remember the quartics have that kind of soft w or soft m, yeah, so we have like two maximum or two minimum. It depends if they go up or down, it depends of the sign of x to the power of 4, which in this case is the coefficient of x to the power of 4, which is 1 in this case, so it's positive, so my two branches go up, yeah? So I have something like a w. We need the roots to represent them, so I have x equals 0, and it's going to be double because it goes square, so that means I have this root twice, yeah? I have x times x. And then another root would be x equals 1, that is single, and x equals 3, that is single as well. When I have a single root, my graph goes across. When I have a double root, it touches, but it doesn't go across, it just bounces, yeah. So we have a double root in the 0. We know it's coming from this side and leaving from this side because my branches go up, and the roots are 0, 1, and let's say 2, 3 here, yeah. So it's going to do something like this. So bounce in the 0, go up, down in the 1, and down in the 3 again, yeah. Something more or less like this. Then second part says, on the same axis, draw the line y equal to minus x. 2 minus x is a straight line, gradient is minus 1, y-intercept is 2. So if we keep, like this is 1 and this is 3, 2, so more or less 1, 2. The y-intercept could be this one, and the gradient is like minus 1. So something like this, yeah, so this is 2. State the number of real solutions to the equation, this one. If you see here, this first part of the equation is the quartic, and this second part of the equation is the line. And remember, when we have one equation like this one, we can think that we are doing the intersection between y equals this function or this line and y equals this function or this line, yeah, which means we are finding a point of intersection between our quartic and our straight line. And from the graph we can see, if I extend this a bit, that we have 2 points of intersection, yeah, so A and B, 2 points of intersection. So there should be the real solutions to this equation, yeah. The number of real solutions will be 2, because we have 2 points of intersection, 2, as we have 2 points of intersection between those two functions, yeah. Then write down the coordinates of the point where the graph with equation fx plus 2 crosses the y-axis. Fx is the quartic, plus 2, I'm moving it up by 2. Yeah, remember this is a vertical translation in the y direction, up by 2. So if my quartic goes up by 2, this point here is going to be here, yeah, so my graph is doing something like this. So the y-intercept is going to be 2. So it's going to be 2, 0, 2. 0, 2, as is a translation. You don't have to explain too much because it's 1 mark question, but in an exam you could say something like, as the quartic has moved up by 2, or this is a transformation, it's a vertical translation vector 0, 2, something like that, yeah. And that's all for this question.